All right, so just to review the things that we have learned how to do.
Yes.
We've learned how to solve an exponential equation when the base is the same on both sides. So what does x equal? 4, right? If the bases are the same, then we set the exponents equal. What if you have to write this down. What if the bases were not quite the same? So let's say if this was like a 16. 16 to the second power. What did we do?
Make them the same.
We make them the same if we can. So 2 to what power is 16?
4.
4, right? Third power is 8, so fourth power is 16. So 2 to the fourth power. Do we all agree that 16 is 2 to the fourth power?
Yeah.
But remember, there was already a 2 up there. So we have to multiply that by 2. So what does x equal? 8. Okay? Last class, we learned, actually the very, very first lesson, there was a log on one side.
Yes.
And if there's a log on one side, what did we do? Left, right, middle. 2 to the fourth power equals x, so therefore x is 16. That's what we just did, right?
Yeah.
And lastly, very last class, we learned if there's a log on both sides, what does x equal? 2. We set what's being logged equal. But sometimes there was a couple logs. So what did we have to remember?
So combine them.
Yeah, we just combined them first, right? And then once there was one log on both sides, we set them equal. That's everything we've done so far. So the only thing we haven't done, you'll find out today. So here it says to solve an exponential equation in which the two sides cannot be written with the same base. Underline that.
Okay.
So like 16 is 2 to the 4th. So I could get the bases to be the same. But what if they're not the same? That's what we're going to do today. So first step, we're just going to do a few examples. It shouldn't take that long. So I'm going to kind of follow through with this blue box right here. First step, use SADMEP. What does that mean? Undo a whole bunch of stuff to get the exponential by itself. So how can I undo divided by 2? Multiply, right? So we get 6 to the 2x minus 1 equals, if I multiply the right side by 2, I'll have 36. So now think to yourself, does this work from the lesson a couple lessons ago? Can I write both sides with the same base?
Yeah.
Yeah, we can, right?
Yeah.
How can I, remember, we keep the smaller one. What's another way of writing 36 with a base of 6? Squared, right? So step 2 says attempt to write each side with the same base. If it works, awesome. You're done, pretty much. So now that the bases are the same, what do I do to solve the exponential? Yeah, algebra 1, we take the exponents and we set them equal. So now we just have 2x minus 1 equals 2. Add 1 over, divide by 2, you get 1.5 or 3/2. So was that anything new quite yet?
No.
No, that was a review. So second step, and you can see it in the box up top, it says, if you can write it with the same base, then do it. Write the same base and then set the exponents equal. You'll be done in like 20 seconds. But now let's take a look at example B. So we still have to do step 1, use SADMEP, so undo addition, subtraction, multiplication, division. How do I get 3 to the x by itself? Subtract over 1. Oh no. Now, step 2 says attempt to write both sides with the same base. So can I write 11 with a base of 3, like 3 squared, 3 cubed, 3? No, that doesn't work. Okay? So this is the new thing. Now let me remind you, do you remember what happens if you have a log of a base and an exponential of the same base? Good, they cancel. So what is my answer here? 4. It would be 4. So what we can do, we can actually use logs to make exponentials cancel. Okay? So what we're going to do we can do anything we want to an equation as long as what?
Do it both sides.
You do it to both sides. So what I'm going to do, I'm going to log base 3 the left side. Why do you think I chose log base 3?
Yeah.
So it cancels out the base of the exponent.
Yeah.
So if that was 5 to the x power, what would I have done?
Got rid of the 5.
Log base 5. What if that was a 12? Log base? Yeah, just whatever number is the base of the exponent, that's the base of the log. Now, I can do that as long as I do it to the other side. So it looks kind of weird, but I need to log base 3 11. So log base 3, both sides. So now, what happens with log base 3 of 3? They cancel. And x is now the only thing on the left side. It comes down to ground level. And on the right side, I have log base 3 of 11. Which, I can throw that in my calculator. Math alpha math, go. Now the directions say round to 4 decimal places. So math alpha math, type in log base 3 of 11. And I got, tell me if you get the same thing, 2.1827.
Yes.
Anyone need help putting in your calculator? C. Example C. Is the exponential by itself?
Yeah?
Yeah, 5 to the x power. That's our exponential. It's by itself. So I want to get x by itself. Can I write 62 at the base of 5? Like 5 squared, 5 cubed, 5 no. So we have to go straight to logging both sides. So what is the base I'm going to use this time? 5. So I'm going to log base 5 both sides. So I now have x is greater than or equal to log base 5 of 62. Math alpha math. Go. Oh, it's an inequality, so it's a range of numbers. But x is greater than or equal to 2.5643. Everyone get that? Now, the only difference between an equation and an inequality is we now have an infinite number of solutions, right? How many numbers are greater than or equal to 2.5643?
A lot.
An infinite number, like 4, 5, all the way up to infinity, right? So how could I write this in interval notation, just for practice?
2.5
Bracket or parenthesis?
bracket.
Bracket, because it's or equal to, right? 2.5643 to where?
Infinity.
Greater than that is infinity and beyond. So that's a good review of interval notation. That's another way you could write the answer. Same thing, different way of writing it. Basically, on a number line, we're saying so here's 2.5643. Every number larger than that, or equal to, would satisfy that inequality. Okay. All right. Try and do, let's have you do E. Do E on your own. So D is kind of weird because what is the base of the exponential?
It's a decimal.
It's a decimal, but that's okay. I can still log base 8.2 both sides. So that cancels out, and I get n minus 3 equals log base 8.2 of 42.5. And then what's the only thing you need to do to get n by itself?
Add 3.
Add 3. So it's just in your calculator, type that in. So you math alpha math, log base 8.2 of 42.5, and then just type in plus 3. Make sure you go out back of the parentheses because we're not logging the plus 3. It's that plus 3. And you get 4.7820. How many of you got that one? No different, just a decimal. That's okay. It's not any different. And then E, what am I going to log both sides? Log base. Yep, so I'm going to log, whoops. I'm going to log base 7 both sides. So the 7's cancel. I'm left with 3x minus 1 is greater than or equal to log base 7 of 21. And now I'll show you the best way to do this in your calculator. So to get the most accurate answer, you want to kind of take this step by step. So math, alpha math, 7 of 21. Go ahead and hit enter. You can get that decimal right. And then what are we going to have to do next to get x by itself? This 1 right here we'd have to add over. So hit plus 1, and then hit enter again. And then after we add the 1 over, what would we have to do? Divide by 3. So you can just kind of keep it all in your calculator as you go. That gives you the most accurate answer because then you don't have to round. So you get about 0.8549.
If we do it all in one step.
So who thinks they can explain this? Brian?
Because the natural log already has a base of e, so if you put it to another e, they just cancel.
Yeah, so natural log is actually log base e, right?
Yeah.
Log base e of e equals 1. So now let's think of this as left, right, middle. What's the base? E to what power is e? 1, right? We want that to be a 1. E to the first power is e. So natural log of e is 1. They cancel out. Okay? So we will need that for letter F. So first step, let's get the exponential isolated. So what do I need to do? Subtract 10. So we get e to the x over 3 equals 4,260. Now, so far, what we've been doing is we've been log basing the base of the exponent. So what is the base of the exponent? E. What log has a base of e? Natural log. So if there's an e, we can natural log both sides. Because natural log's base is e. And what did we just learn? Natural log of e is what? 1. They cancel out. And I'm left with x over 3 equals the natural log of 4,260. Now, the biggest thing that people forget to do is they forget to natural log both sides. So you're like, oh yeah, natural log cancels out the left, but then you don't do it to the right, and then you end up getting a wrong answer. So make sure you do it to both. And then what's the only thing I need to do to get x by itself?
Multiply by 3.
Multiply 3. So, and you can use the ln button, right? So on your calculator, ln, natural log, natural log of 4,260. Make sure you close your parentheses, or you can hit enter. And then multiply that by 3. And you get about, did I do something wrong?
It's 4,270.
60.
4,060. You have to subtract 10.
What did you get? I got 20.
That's right. I guess I just wrote it down on my paper wrong. That should be right. Is that what you guys got?
Yeah.
So 25.0711. 1. Because if the 7 would round up to 0, right? So if you're watching the video, you can follow along to what I have so far. And then how do we cancel out e?
ln.
Natural log both sides, not just 1. So I get negative x equals natural log of 9/5. And then I need to divide by negative 1. So therefore x is negative 0.5878. Negative 0.5878.
Nice.
Okay, last one. Do number H, letter H. So natural log is log base e, left, right, middle. Now, remember, I'm not solving for e. E is a number. So what do I need to do to get x by itself?
Divide by 5.
Divide by 5. Now, on the EOC, your answer would probably look like this.